Hey, good afternoon, everyone. Welcome to this afternoon's presentation, Operations at the Center for High Throughput Computing. Your presenter today is Brian. He will be kind of walking you through the operations at CHTC. He's going to pause in about the middle here, take a couple of questions or so, and then at the end we'll take a few more questions based on how much time we have. So given that, we'll turn it over to Brian.
Thanks, Chuck. Can you guys hear me in the back okay? Perfect. Great. Hi, everybody. I'm Brian Lin. I am the CHTC Infrastructure Services Lead. And today I'm going to be talking about how we do operations at the center. But before I dive into those details, I'm going to give you a quick overview of what the center is all about. So what is the CHTC? The CHTC was established in 2006. It aims to bring the power of high throughput computing to all fields of research and to allow the future of high throughput computing to be shaped by insight from all fields. So what does that actually mean? So if you have researchers and their workflows look a little bit like this, they probably have on their hands what we call a batch job, or just job for short. And a job is just a piece of code that has a concrete start and end time and doesn't require human interaction to complete. If your users, if your researchers are complaining about their computers sounding like it's going to take off or it's unresponsive when they are running their jobs, then high throughput computing may be for them. And the idea behind high throughput computing is that the researcher can take their job and break it up into smaller constituent pieces, and then send each of those pieces to different computers. They will compute the results, those jobs will run, and return back to them with said results. But if your researcher just wants to run one job or tens of jobs, then going through the time and effort to learn high throughput computing may not be for them. We really want researchers to come with us thinking about how to run hundreds of thousands of jobs, millions of jobs. We want them to think about how their research can be transformed if they didn't have any constraints on the computing capacity available to them. We want the researchers to be asking the deepest questions about our world and our universe. So, like, what gives objects mass? How does that mass affect the space-time fabric itself? What do cows really look like? But in all seriousness, all of these experiments are supported by high throughput computing. One of my favorite stories from a researcher was from our conference last year, Throughput Computing 23. This was from Rosaline Larson, and her mother was diagnosed with multiple myeloma. And Rosaline wanted to analyze natural compounds to find different treatments using protein docking as alternatives for multiple myeloma. And so her lab had a rack of servers, and she figured that she would be able to go through a small database of compounds over a couple of years. She found high throughput computing, and she was able to run over 40 million docking runs in the span of a month using high throughput computing. I don't know exactly how many compounds that adds up to, but it definitely changed her view on what she could do with her research. So how do we actually...
I'm sorry.
No, you're fine.
Oh, and I got your slides. They weren't seeing them online.
Ah.
So maybe I missed it.
Can you guys see the slides online?
Yep.
Perfect.
Are you able to?
Yeah, perfect. Awesome. So how do we support this? Well, we have campus computational capacity. We have a high throughput computing cluster that consists of over 600 execution points. There's an asterisk there. I will get into that later. We have over 200 GPUs. This CHTC cluster is federated with other campus clusters. So there are other units, departments on campus that run their own high throughput computing cluster. But if they can't meet the demands of their researchers at the time, maybe they need GPUs, maybe their cluster is just busy, those jobs can then be shunted off to the CHTC. We also run a high performance cluster, a Slurm cluster with InfiniBand network and high speed interconnect and all that sort of stuff. We have 200 worker nodes, and you may be asking, why is a Center for High Throughput Computing running in HPC? And that's just simply because not all workloads are favorable for HTC. These resources are open to all campus researchers. We do offer prioritized access as part of faculty startup packages or purchased hardware agreements. But a very important part of that is that this is just prioritized access. You don't necessarily own the machine per se. When you or your group are not using these resources, they are contributed back to the general campus pool. And in our bid for world domination, spreading the gospel of high throughput computing, we don't just look around campus. We look nationally. We look globally. So we take part in the OSG consortium. This is a distributed high throughput computing setup where there are many sites consisting of national labs, academic institutions that contribute resources to research. And the idea here is that at any given institution, you can imagine we're just one university out there of very many. All of these other institutions have their own computational clusters for research, and they pay good money for them. And so if your servers are not active, they are basically just very expensive, very loud, very heavy, very energy inefficient paperweights. And so these resources are generally paid with taxpayer funds, so we need to be good stewards. And so when there's a natural ebb and flow often on campuses where there isn't usage following the cycle like the semester, for example. And so when around the semester, we can take jobs from outside and run them and contribute to experiments around the world. So the OSG consortium is made up of multiple distributed high throughput computing pools. Some of these pools are dedicated for some of these multinational experiments, like at CERN, LIGO, the gravitational wave people. And the reason they may have their own pools is because then they can set their own policy within said pool. We do help run the Open Science Pool, the OS pool. It's open to any researcher affiliated with a US academic institution. And the system that we use is dynamic in that we, whenever we contribute resources to the OS pool, it happens on a lease and it's based on demand from the national infrastructure. And if there isn't demand, then they won't ask for anything. And so the size of these pools will ebb and flow. We also partner with the NSF CC STAR program. This is a program where they are providing grants to smaller institutions to help them be part and contribute to the research cyber infrastructure. So if a campus is awarded one of these grants, they come with strings attached. Generally, they say that 20% of the computational capacity that you purchase with this grant has to be contributed back to open science. And many of the campuses contribute back to the open science pool this way. We also offer the Path Facility. The Path Facility is a dedicated distributed high throughput computing system. So unlike the OS pool, it doesn't ebb and flow in size. But it is not necessarily open to all researchers in the way that the OS pool is. You have to apply for credits through your NSF program officer. We also run the Open Science Data Federation. The Open Science Data Federation is a way for us to tackle the problem of distributing big data within this geographically distributed infrastructure. So we work with folks from the National Research Platform and all that stuff to deploy caching infrastructure within the research network backbone and throw services in front of the actual data origins, so we can efficiently move data around the country, around the world, to where the compute is happening. I highly recommend going to this website here in the bottom right, osdf.osg-htc.org. That's where I stole the image from. I couldn't get the screen capture to work, but it's a really fun animation to look at, and it's interactive and stuff. So the CHTC itself is a research center, and we believe in translational computer science. So the idea of translational science was stolen from the medical sciences field, and the idea is that, well, researchers have an idea, and it wouldn't be responsible to just shove that idea onto the general populace. So you run some experiments in a smaller area, maybe in a clinic, and then you expand that to a couple clinics. And then once it is robust, you get some feedback from this process, then you distribute to the general populace. So the CHTC produces open source software used by companies, labs, and academic institutions across the world. The HD Condor software suite is the core of this and predates the CHTC. It started as a cycle scavenger. So on the CSL labs desktops, overnight or when they weren't in use, would run researcher jobs. It powers high throughput computing, and in places that you maybe wouldn't expect. We generally have somebody from DreamWorks attend our conference because their entire rendering farm is based on HD Condor. And this past year, we started officially the Pelican Platform software project. And this is the software that undergirds the Open Science Data Federation. And we have a saying in the CHTC, it's that we eat our own dog food. So we run the latest HD Condor and Pelican release candidates. And the idea here is that we are there to sniff out critical bugs, test new features before the general populace has to. Speaking of eating our own dog food, one of the services that we offer is called XDD, or Extracting Dark Data. It heavily uses the resources available, the high throughput computing resources available in the CHTC. It is a partnership with the libraries, and it is a pipeline that processes journal articles and does natural language processing of text, visual parsing of the PDFs, and then allows researchers downstream to do searches on this stuff, to do meta-analysis. So this was very interesting during the height of COVID because there were a lot of coronavirus papers going out, and so there could be this helped with the meta-analysis there. XDD itself is backed by Kubernetes services, and we have a lot of data, a lot. One of the most important services that we have is our research facilitation services. So we have a team of domain scientists who can talk the computational lingo. And so they help the researchers go from laptop to high throughput computing cluster. And they do this with personal consultations. They offer many trainings around campus and then also nationally with the OSG consortium. They offer workshops. We have an annual OSG school here every summer where we basically make that promise that you will go from jobs on your laptop to running actual research in a high throughput computing system. They also offer regular office hours during the week. And they are an important part of our translational mission because they are our front line talking with the researchers, the end users. They know all the trials and tribulations and pain points that they have to go through, and then can feed that back to the software team, and they can together make decisions on strategy and design of new features or fixing old problems. One of my favorite stories, or one of my favorite projects that we worked on over this past year as a center, was a partnership with the National Radio Astronomy Observatory. So these guys had a I think it was about like a 12-year-old data set. It was really big, 2 terabytes, and it was like basically a pixel in the sky. I think they were looking at the Hubble Deep Space picture or area. And they tried as they might over the past few years to actually process this raw data. They tried a couple of years ago at some of our nation's supercomputers, and it took about a month to do. So we partnered with them. We used the OSDF, we used the path facility, the OS pool, got them access to lots of GPUs, and basically they were able to process this data set. It was like 20 gigs of data per job or something like that. They did it in about like 1 or 2 hours. And so we're really excited to see where they go with this. We found all sorts of bugs in the software, issues in our infrastructure. And so this feeds back into our mission of we want to push research with high throughput computing, but we also want to learn from the researchers. And that's intermission. You guys have any questions about that?
There was a question in the chat, which was answered in the chat.
So this question has been answered in chat, but I'll pose it for you to answer and potentially expand on for the room. So Julie asked, when data is processed outside UW systems, how are security standards maintained according to data classification?
Right, so the idea of a lot of the data that we process is that it is generally open data. We don't, as a center, work with restricted data generally. If you have restricted data and need the computational capacity of the CHTC or maybe not the OS pool, we should talk. Alrighty, so I'll hop into details about actual operations. So this is my team. We consist of 4 sysadmins and 4 integrators, as we like to call them. An integrator is some days DevOps, some days software developer, some days just kind of smashing 2 pieces of software together and seeing how it works, that sort of thing. And our mission is to advance the research goals of the center by providing a stable foundation of hardware, batch computing, and auxiliary research computing services. To start things off, let's start at the hardware level. We manage about 1,100 physical hosts, 150 virtual hosts across 5 data centers here on campus and at One Neck, one of the off-campus data centers. We did not buy all of these hosts in one fell swoop, surprisingly. So heterogeneity is a lived experience for the CHTC. Inventory tracking is a bit of a challenge. Going back to my asterisk of having about 600 execution points in the CHTC pool, I have about 4 spreadsheets. I'm a pointy haired manager, so spreadsheets are my love language. And those 4 spreadsheets give me 4 different numbers. I believe some spreadsheets more than others. So that's how I got to the 600 number. But it is a challenge. And as I mentioned before, servers that aren't doing anything, that are sitting on the floor, are worse than paperweights. So it is really important for us to get from server being delivered to actually running services, running jobs, what have you. We use Cobbler to install operating systems on our servers. We run Puppet for configuration management on those servers. We have 4 different operating systems. They're all Linux flavors at this point. We have 2 different CPU architectures and 82 different kinds of hosts, basically. Like I said, heterogeneity is a lived experience at the CHTC. So the batch computing services, I'll kind of just blow through these. We have the high throughput computing cluster that runs Condor. We have the high performance computing cluster that runs Slurm. We have a lot of auxiliary services. We have 3 Ceph storage clusters, 4 if you count our test cluster. Our biggest one has 4.5 PB at this point. But that is to say that CHTC is not a storage service. This is for live job data, job input and job outputs. It's not archival, there are no backups, we make no guarantees. We also have user management pieces of software, Elasticsearch, Kibana, Barrows. We have a lot of different stuff that we have to worry about. We also run Kubernetes in CHTC. We have a multi-tenant Kubernetes cluster that we call Tiger. It's used to deploy CHTC services, OSG central services, and then we also work closely with a bunch of these large experiments and run some services for them. I won't go through all the details, but if you're a Kubernetes nerd, come find me after and we can talk on why we made decisions on one piece of software versus the other. Though this slide was really fun to make, looking up all the different logos of these things. This cat for Calico, this unidentified rodent for traffic. We also work on a lot of Kubernetes clusters outside of the CHTC. We collaborate very closely with friends at University of Chicago. They run a couple of Kubernetes clusters, and we run OSG central services there to make sure that they are highly available. In the past, we've had some catastrophic experiences at a single institution, and so I want to make sure that we have that failover available to us. As I mentioned before, we also work with the National Research Platform for deploying services across the country in the research network backbone. So that's mainly the OSDF caches. The path facility itself is also made up of multiple different Kubernetes clusters. 6 in total. 4 of them were actually built and provisioned here at UW-Madison. And then we took 3 of them and shipped them across the country. So we have hosts that we manage at Florida International University, Syracuse University, and University of Nebraska-Lincoln. We believe in GitOps. And I think it was Mike Collins earlier today that talked about DevOps. We live and breathe that because otherwise I couldn't make sense of any of this nonsense. So GitOps is tracking and making operational changes with Git, so version control, and then using continuous deployment systems to make those changes a reality in the production services. This is important because the service states are enshrined in history, allowing for rebuild in case of catastrophic failure, which, as I mentioned, has happened before. Version control is incredibly important because it tells you who, what, when, and hopefully why we made a particular change. It's really great for knowledge sharing because sometimes I will have a team member make a change to one particular service, and another team member will need to make a similar change to a different service. And so we can point them at the Git commits as a starting point. GitOps and this shared state of understanding of what the production services should be in is really important when working on a team, especially a team that is spread across time zones. So for the OSG services, we do collaborate with folks from other institutions, and they help run some of these central services. We also use internal Git repositories for our Puppet configuration of managing our hosts. Right now, that is not, I wouldn't describe that exactly as GitOps because there's no CD involved, but I really want to get there. We also have monitoring. It's absolutely crucial in these types of environments. We have real-time monitoring. We use Prometheus, Isinga, depending on the service. Our friends at the University of Nebraska-Lincoln run CheckMK, which is really nice to have this external check of probes. Is this service alive? Because if your checks are just running from within campus, then you may not know the whole story. We have various monitoring dashboards in Grafana and Ganglia. We do accounting of job utilization and dump that data into Elasticsearch. This tells us who used, how much, and when. We also have all sorts of email reports with usage metrics. I am buried in email. And also in our spare time, we are responsible for the OSG software stack. So we build, test, and distribute an integrated software stack, which allows sites to contribute their resources to the OSG consortium. We don't actually own any of the software. It's all open source. We pull it in from various upstream providers, and kind of like I was saying, the integrators will kind of take two pieces of software and jam them together. They will round off any rough edges, maybe do a bit of development to build some glue software and write some patches to make sure the software integrated is functioning as we desire. And sometimes we have to manage the software lifecycle. So an upstream provider may stop supporting their particular open source piece of software. And so we have to work with the community to help provide transition plans, a bridge for them while the software is not supported upstream. So what are we working on today? Some of the big projects, spinning up the UW Data Federation. So this is a federation outside of the Open Science Data Federation. We will be distributing data via the Pelican platform. And we're going to be collaborating with the libraries, research cyber infrastructure, to make the most open data available from minds at UW, allow researchers to access their data in a research drive and the research object storage. We're also in the midst of a lot of operating system upgrades. Two of our major operating systems that we have installed across the cluster are, in the next 34-ish days, reaching their end of life. So we've got our work cut out for us. We also do a lot of training. So we have 2 to 3 interns at any given time. They help us a lot, especially with hardware failures, replacing disks. They help us with big projects like operating system upgrades right now. They are helping rebuild these hosts on a supported operating system. I'm really excited for the CHTC Fellows program, which is starting next week. And we are having a cohort of 8 fellows, 3 of which my team are mentoring. And basically a fellow is different from an intern because they submitted an application with a particular project in mind. They wrote a project plan with milestones, deliverables, all that sort of stuff. And this program runs through the summer. And so they're going to have check-ins. They're going to give talks at our conference later this summer and get a lot of great experience, we hope. This is our first time running this thing. And I think I've seen Carolyn around. I know that I owe her I owe her a project description because we do want to be a host unit for the Job Rotator program. We think it's really cool. One last thing, I want to plug our annual conference. We are hosting Throughput Computing 2024 here in Madison. The dates are July 8th through 12th. In-person registration closes on June 28th. Virtual registration is free and I don't think closes. And you can find all that information at this link here. I think, oh, no, special thanks to everybody in the Do It data center and networking teams, Discover IT, the CSL, Todd Schechter, and the Research Cyber Infrastructure Group for all their support. We couldn't do it without you guys. And that's it. Questions?
I have one for you. What's your oldest hardware in the CHTC?
Oh, going back to those spreadsheets. I think it's 12 years old. I really want to get rid of it. I think Vince had a question.
Hi, Vince with Testing and Cyber Defense. You said you got emails regularly that are automated? Are they automated out of Elastic, or do you get those through Git?
They come from a variety of locations. I'm really aiming to try and consolidate. We have all sorts of cron jobs living on different hosts. Some of them send email. I'm trying to consolidate them to our Kubernetes cluster, where a member of my team set up a postfix service that talks to campus SMTP and all that stuff.
Sorry, I missed the name of that, but could you talk more about the UW data, was it Discovery?
Data Federation.
Federation, could you describe that more about what that looks like and what that is?
Yeah, so first off, we are aiming to make data in Research Drive and the research object storage available to researchers that are doing work on the CHTC. So they've put their data sets in Research Drive, and we're working on the integration using Pelican so that they can read from it and write to it. You know, things are protected with bearer tokens and all that sort of thing.
Okay, so it's not meant to be like an inventory of data that may exist that other researchers might be able to use. It's just,
Yeah, at least that wouldn't be for Research Drive.
okay.
Mine's at UW may be different because it is a data repository.
Okay.
Hey, I'm Christian from Platform X and SMPH. I'm a weirdo and I'm obsessed with monitoring. I want to hear more about your Prometheus stack. Do you have it, distributed? Are you sending alerts to both yourself and customers? Are you providing Grafana dashboards to customers? What is like?
Everything you described is a dream of mine.
Same. That's what we want to do too.
Very early stages. We're still relying very heavily on Isinga locally, but for Kubernetes, it's all Prometheus all the time. We're developing expertise as a team on making sense of those metrics and then doing sensible alerting. Right now, I am buried in email alerts, Slack monitoring channels that I just ignore because it's too much and we need to fine tune it.
If you'd like to collaborate, let Mike know.
Would
'cause-
love to.
Yeah. Okay. Awesome.
All right, that's going to wrap it up here as we're out of time. Let's give Brian a hand, everybody, for his presentation.